Now these questions, they are from your textbook. It is not necessary the given the given the probability find the z-score. No, it can be both types. They mixed up together in one question, right? Or maybe for the start, they ask you the first type first, using the calculator type, not the type that use the table. Anyway, you read and see. Question number one. Li Ying, read question number one.
Okay, teacher. Given x is a continuous random variable that is normally distributed with a mean of 210 and a standard deviation of 12, find the z-score if x equal to 216, x if the z-score is negative 1.8.
They have two parts. The first part, find the z-score if x is 216. Okay, so this one you use the calculator. X if the z-score is 1.8. No, they don't ask you to find probability. They just ask you to find standardization, the standardization formula, right? So let's see. First one. So the standardization formula is z equals to x minus mu divided by sigma. What is the mu? 210. So we're going to substitute this 210 inside the standardization formula. And they say the standard deviation is 12. So we're going to substitute this number 12 inside the sigma at the bottom. Okay, so the first part, find the z-score if x is 216. So they tell you this x here is 216. So you substitute everything inside the formula. Z equals to 216 minus 210 divided by 12. The z-score is 0.5. The part B is also the same. You use the same formula, substitute in the value, then find the x. So how? Look at this one. The z-score is negative 1.8. So the z-score is negative 1.8. X minus the mean 210 divided by sigma 12. To solve this equation, x is 188.4. So you have to solve the equation. Read question number 2.
Okay, teacher. The diameter of basketball produced by a factory are normally distributed with a mean of 24 cm and a standard deviation of 0.5 cm. The diagram on the right shows the normal distribution graph for the diameter in cm of the basketball. Given that the area of the shaded region is 0.245, find the value of k.
This one, they are referring to the diagram, right? If you look at the diagram there, the center line is 24. The center line, the peak, the top, then the center is 24. So this 24 actually is the mean. They are trying to tell you 24 is the mean. Standard deviation 0.5, right? Okay. Then find the area of the shaded region. Okay. So the shaded region is between K and 25.4. Okay, right. So we say that the x is the diameter of the basketball and x is distributed normally with mean 24, variance 0.5 square. Normally inside the bracket we talk about the variance, but in the formula we talk about the standard deviation. Okay, next one. Now the diagram shows us the probability, right? The probability between k and 225.4, right? This shaded part shows us the probability that x lies between k and 25.4. So given the area of the shaded region is 245, so the probability is 245. Find the value of k. Okay, now using our standardization, we are going to convert the K to the Z-score. We also convert the 25.4 to the Z-score, right? Because it is only through the Z-score that we can relate it with the probability. Using the X-score, we cannot relate unless you invent, or not invent, like you go and calibrate another table for this particular distribution. So we don't know how to calibrate either. So we just use convert to Z-score, convert to Z-score. So convert the 2 to Z-score. Now this probability, the probability at the center here is the probability greater than K minus the probability greater than 2.8. Actually, this is 2.8. This one. This number here, this number here, 25.4, when you change to Z-score, it will be 2.8. It's 2.8. Right. Then you want to find the probability of this purple color. The probability is probability greater than this number minus the probability greater than this number, then you will get the purple color. So that is what I've written here. You cannot be referring to this diagram here because this diagram is for X. What I'm doing here is for Z, the standardized score. Right? Now, why change to standardized score? Because I can actually find this from the calculator. Z greater than 2.8. Can you find Z greater than 2.8 from the calculator and see what is the value? With your calculator. Z greater means you use R 2.8. Or you look at the table 2.8. Oh, here 0.00256. Is that correct? Never mind. We use the calculator and see. Yes, correct. 0.00256. So the probability of Z greater than this is this probability equals minus this 2.8 is equals to this probability. Okay, never mind. Right. So when you move this over, so it is 2475. 245. Move over, you have to plus, add this number. So it's 2475. Now this is the case of the given the probability, find the Z-score, because this number here is the probability. So you have to refer to the table 2475. 2475. Okay, 2475. Where is it? 2475 is here. 2483. 2475 is between 75 and 83. Difference is 8. The difference is 8. No 8, but got 7 here. So it's 2. 682. So answer is 0.682. So the Z score is 0.682. 0.682. But the Z score is this fellow here, this thing here. So you try to say this is the Z score from your standardization. This is the z-score from the table. So they are the same. So I solved for the value of k. So value of k is 24.34. Any questions so far?